So we also talked about empirical formula in the other chapter, in chapter 2. When we talked about it, it was the smallest whole number ratio. And I just remembered it. So like if I was in class, what I would do is I would stop, because I'm trying to keep this interactive and I'm trying to keep you engaged in thinking about it. So I'm going to go ahead and pause. And I've used this one and this one. And you go ahead and fill in the other ones. So pause the video. Give yourself a chance to think before just getting the answer. Okay, so those ones are empirical formulas. C12 is not an empirical formula. The physical and chemical properties are often very different. Whether the molecule is the empirical or molecular formula can be determined if you are given the mass of one molecule or compound and have calculated the molar mass. This is the same thing as saying molecular mass or formula. It's meaning get that number off the periodic chart. So just to review it, empirical formula is the smallest whole number ratio of elements in a molecule. So those three guys we just talked about, those are the smallest ratios. Like a ratio higher would be like Na2Cl2. They are empirical formulas. C6H12 is not. The empirical formula for that would be CH2. The physical and chemical properties of empirical and molecular formulas are quite different. It's like the difference between saying that something is a gas and something's a liquid. Like they can be hugely different, especially the larger the molecule, the properties become very different. Okay, so whether the molecule or compound is in the empirical or molecular formula, it can be determined if you are given the mass of one molecule and you've calculated the molar mass. So this is a lot of words that actually says something that's really simple. So this is another simple math. You've done this before. I promise you've done this kind of math before. Just not maybe with compounds. So here's our example. What is the molecular formula for this? So this is saying this is the empirical. We have the empirical. What is the molecular formula if the molecular mass is this amount? Now, if you do the C2H5, and I did this one up here. I believe I did this one on the first page. Oh, no, I didn't. Okay, so this one you would do from the periodic chart, and you would just do 2 times the 12.01 plus 5 times 1.01, and you would be getting this mass for this compound. So you take the big one, you put it on top, and then the little one is on bottom. You do the math, and it's going to come out to being like whole numbers. It'll be like a 3 or a 2 or a 1. The 3 means that's what you are multiplying all the subscripts by, not just one of them. Make sure you get all of them. So, again, that 2, I'm going to change the color really quick. So the 2 gets multiplied by 3. And then the 5 gets multiplied by 3. So you get it? You just do the big number divided by the little number. Ends up being 3. All the units all cancel out. And then multiply by whatever that turns out to be. All right, so I got some examples for you. What's the molecular formula of this guy? Here's your molar mass. Oh, I left off a grams per mole. I'm sorry. Should say per mole. If the molecular mass is, and we have these options. So you pause the video and you think it through. Again, that's the big number divided by the 30.03. All of these numbers are divided by 30.03, 30.03, and 30.03. Probably can see this without even putting in your calculator. That one's going to be 2. This is going to be 6. This is going to be 10. And this is going to be 1. So, interesting on that last one. We'll have to do comments on that one. So just multiply all those subscripts by 2. So that will give me C2H4O2. Next one, make sure I'm always going up to this. Don't try to like go to that. That won't work. Always got to go to the empirical to get this. So C6H12, that's a 6, O6. And then with the 10, again, you're going up. C10, H20, O10. And then this last one, CH2O. So what this last one is saying is that we actually are talking about that molecule. It is the empirical formula, but we also are talking specifically about that one. So it is that one's molecular formula. So you can be 1. And that just means you multiply all the subscripts by 1, which means you're talking about the same thing as the empirical. That only happens sometimes, but I just wanted to throw it out there. I didn't see any examples of that in Newton, but this definitely comes up in organic chemistry. So if you're going to be taking organic, you're going to be getting this concept coming up again. And then I have just a little thing right here. So we were talking about these percentages and these molecular and empirical, and you're probably like, well, why do I care? Okay, so we have some instrumentation. There's gas chromatograph, gas chromatography, and mass spectroscopy. These are super common instruments in any lab. They've got like tons of them, more than one at like UTC. Like it's super common, and it's used in the industry. So they're going to have these at companies that deal with chemicals. It's in the industry. It's super common. And like in the case of gas chromatography, like you dissolve a sample of something, you want to know what its composition is in water, or not in water, in some kind of solvent, and you just squirt it in the machine and out pops an answer. You have to like analyze it a little, but out pops an answer. And like mass spectroscopy, it kind of works the same way. It just depends on what you want to know. They do tell you more than this. But one thing it can be used is to verify percent composition and see if something is actually pure.